guys. Is it on? You hear it? You guys hear me? I don't think I can hear me. You guys don't hear me, right? Test. It seems fitting my mic wouldn't work because we're going to talk about things working and not working today. So thank you everyone for joining us. I'm Alexis Rappo. I work in the digital team, and we are thrilled to have you at this talk. I'm going to introduce in a moment our panelists, but we're thrilled that you're here. I want to tell you a little bit about our Roblox game, Mission Mars. We launched this game in December. For some of you, I'm seeing some familiar faces. You were up at our panel a little while ago on the upper level. Mission Mars is a game that we developed with Roblox, intended to help you learn about how to design your rovers, how to drive them, how to navigate them on the surface of Mars. And it's a pretty incredible game. We've had 2.5 million plays since we launched it, and if you haven't played it, I would love you to. How many people in the room are Roblox players? All right. How many are going to be Roblox players after today? Just Mission Mars parents? All right, awesome. All right, well, I'm thrilled to have you all joining us today. I'm thrilled to introduce our group here. Today we're going to talk about engineering both in the design world of games and game experiences, and how that relates to design and experiences when you're taking a rover and putting it on Mars. I was going to say the moon, but that's just the halfway point, and it doesn't end up there and isn't there. So I would love to introduce our group here that we have today. So moderating is going to be, oh, sorry, I cannot see my notes here. Oh, I'm so sorry. We've got Louvere Walker-Hannon, and Louvere is with MathWorks. She's a MathWorks engineer, an application engineer, a senior lead design, and she's a STEM advocate and a volunteer extraordinaire. So thank you. She's going to take over for me in a moment. We'd also like to introduce you to Nagin Cox, who's on the end. Nagin is a tactical mission lead on Curiosity Rover and Perseverance. And we got a chance to talk over lunch, and she calls Perseverance Percy, so it's very personal. And she'll tell you a little bit more about what she does in a moment. I'd also like to introduce Genevieve. Genevieve Johnson is a senior instructional designer for Roblox. She creates educational content and advises educators. She advised us and worked really closely with us on the development of our game. And then last but not least, I'd like to introduce to you Peter Wonica. He's also an instructional designer for Roblox, and he creates educational content for students and developers and helps empower them to build their skills. So we have an incredible panel today. We're so happy you're here. We'll tell you a little bit more after the panel for some things you can engage with from a Mission Mars perspective. And with that, I'm going to hand it to you. Go ahead, Lou.
Okay, I hope this is on. So let's see if it is. Okay. So first of all, thank you for the introduction as well as welcome. And I hope you're as excited as I am. So let's get started. Let's meet the panelists. So for each of the panelists, I'd like to ask the following questions. So who are you? As well as where do you work? And if you're a Robloxer, what is your Roblox username? So we're going to get started with Genevieve and then continue from there.
Hello. So I feel like who are you could be a really deep question, but I am Genevieve. I work at Roblox, as was mentioned, and my Roblox name is Chirple, and it rhymes with purple. I'll pass it off to...
Hi, and my name is Peter Wonica. I work at Roblox, also been at the company for 5 years, and my Roblox username is BudgetFox.
Hi, I'm Nagin Cox, and I work in Pasadena, California at NASA's Jet Propulsion Laboratory, and I'm a tactical mission lead on the Mars Curiosity rover and the Mars Perseverance rover, and I do not have a Roblox username, but that's something I'll correct shortly.
We'll help her.
This is great. Thank you for the introduction. So let's continue. These are questions that are specific to each of the roles that you heard about a few minutes ago. So I'll start with Peter and Genevieve. So, in real life, what does a day in the life of a Roblox engineer look like? And either one of you can get started.
Sure. The first I want to point out that at Roblox, there's lots of different engineer types. There's lots of people who are working on lots of different problems. So probably one of the first big buckets are the people who are making the tools that other people are going to use to create all of the 3D experiences, all of the video games and simulations that you actually see on our platform. So they're making games that can help you simulate a storm, or help you simulate physics in your game, or make the lighting look really good. There's all kinds of math in that. Like if you want to think about how light reacts as it interacts with water, there are people whose their whole job is figuring out solutions using a lot of math and algorithms and even AI to make those tools. On the other side, there's a lot of people who, once you get to the video game, so you got to think about, first you got to make the game, and when you get there, their job is to make sure that you can get on easily, that you have a fun time, that you are safe, that it is a great place to come and visit. So they might have jobs like working with the servers to make sure that like the game feels really responsive. I think a lot of you have been on the internet, you know what lag is, you know what it's like when things are going really slow. So somebody on the other end is actually watching some diagram somewhere and being like, huh, that doesn't look the way it's supposed to look. They're like, oh, there was a giant dip in these numbers. We're gonna go take a look at that. Or they're also thinking about things like, how do we make sure that I can have a conversation with you, Lou, but that I can't call you bad names, or I can't maybe bring up things that shouldn't be brought up in certain circumstances. And that's a really tricky job. When you think about the English language, things can sometimes be, you know, a good word or a bad word. So once again, these are lots of different types of jobs, but whatever your specialty is, and for me and for Peter, that's education, thinking about how do we help people learn. You're going to be creating something, you're going to be looking at a lot of data and gathering information from people to think about like what do they want, what do they need, what are their pain points, and then you're going to be coming up with a solution, going to talk with other people. You're like, hey boss, does this make sense? Then you maybe talk to some other people and they're like, no, that doesn't make sense at all. So you come up with a plan, then you make something, and you're like, hey, look, I solved the problem. And someone's like, oh no, that didn't solve the problem at all. So then maybe you start at the beginning, or maybe they're like, oh, thank gosh, now this is so much better. And then we call it deploy, when we put that out to the public. So no matter what job you have, there's that same pattern every day of you're thinking about what's the problem, yes, what's the solution, or what do you think might be the solution is actually what usually happens. You test it out. Yes. Maybe you got it, maybe you didn't, and then you put it out to the public.
Okay, this is exciting because there's probably going to be a theme of following an iterative process, which is a lot of what was just described. But let's see if there's some overlap with Peter and then going on to Nagin. So Peter, what about yourself?
Yeah, so kind of thinking about what a Roblox engineer kind of does in day-to-day life. So one of the things I do is actually work with a lot of the Roblox developers who make their games. So for instance, Mission Mars, the game that was actually developed, I actually work with a lot of those engineers just to kind of help them through a lot of their issues. Like, why is the Mars rover flying right now? Mars rover shouldn't fly. So part of that really just means you oftentimes just kind of look through almost lines and lines of code to try and figure out like, oh, what is this actual problem? It's a little bit sometimes like, it can be really easy. It's like you're on a beach and there is a big giant neon green ball that you know where the problem is, you know how to figure it out, or sometimes that issue can be as small as a pebble and you're spending the entire day kind of looking through it. It's a lot of just kind of work to actually kind of figure out where this code works, how to actually fix it.
So in other words, it sounds like there's a lot of problem solving as a part of the role. And let's see if there's overlap as we check in with Nagin. So what does a day in the life of a NASA systems engineer look like?
So what do we do at NASA in the part that I work in? It's very similar to what Genevieve and Peter were talking about. So I work in robotic space exploration. So I'm not an astronaut, but before we send people, we send robots. So I work in mission control, just like you might have seen in the movies, except we're talking to a robot instead of to an astronaut. So our day starts with, just as Genevieve said, the same kind of thing. First, you get the data. So we get the data from the rovers on Mars, and we see how things went. What happened the day before on Mars? If Perseverance was supposed to drive, how far did Percy drive? Did she get as far as we needed the rover to get? And then based on that, a group of people that I'm part of, we will figure out what do we want to do the next day on Mars. And then once we know, we lay out her plan of activities for the next sol on Mars, the next day on Mars. And then we turn those into commands, and by the end of a mission control shift, we have her program, her commands for the next day that we are then going to send through one of our big antennas to Mars so Percy knows what to do on the next day. And if things don't always go right, we do the same thing. We look at the data, we figure out what went wrong or what we want to do differently, and then we change what she'll do the next day. So whether you're working with a simulation of what's happening on Mars or what's actually happening on Mars, the basic skills and the basic approach is the same of of understanding your data, problem solving, and then using it to fix whatever's wrong or to move on with what you're trying to explore or learn.
That's very helpful, thank you. And there are some themes that have emerged. So planning, problem solving, and data analysis, which is also a part of my role as well at MathWorks, where for most of what I do, I work with customers who are trying to implement AI and data science as a part of their applications. And I follow those same steps that each and every one of the panelists highlighted as a part of that role. So this is great. It's awesome to see that overlap. And we're going to switch gears a little. And this is going to be, I think, an interesting question. So, a series of questions. So, switching gears and thinking about games, here's the next question. What is or was your favorite game? Also, do you play tabletop games or video games? So let's see if anyone wants to start with an answer. Anyone? And then we can continue from there. Any preference?
I can start first.
Okay, Peter's first.
Yeah, so I honestly play a decent amount of games. Sometimes a lot of the games I play, just because I look at a computer almost all day long, oftentimes have to be handheld. I love playing a game of Uno, for instance. It's really quick and easy to play, but also I'm a big fan of a lot of video games, whether it's playing Roblox or role-playing games, and even kind of creative games too. I'm a big fan of making anything in a game that I can.
Let's see, so I don't play as many video games for fun because we kind of already are doing that in real life on Mars. So during my workday, we are in fact getting data back, trying to figure out from long distance what the rover is doing and looking at simulations of that. But when I am playing games, just like at work, I actually like the collaborative ones. My favorite board game was Pandemic, and and now we've all lived it. But and I liked it because it was collaborative, because we were all working together as a planet to try to solve this problem, which reminded me so much of work And besides that, I also like charades, because sometimes when you've been, as Peter said, when you've been in front of a computer all day, it's fun to interact with people and laugh, and charades always makes me laugh.
I am a big gamer. I'm usually playing a few different types of games on any particular day or week, and I use it a lot to connect with old friends. So particularly during the pandemic, every Friday I get together online with people I haven't seen in person in over a decade, and we all will pick a game and we play together. I also play a lot of tabletop, but I did also want to point out something we just discovered chatting is that we're all really inspired by media in general. So that was a big influence on all of us growing up in terms of how we got to where we are, watching things like Star Trek or reading science fiction books.
Absolutely, and I have to say this, so in terms of games, years ago I used to be better about playing games, but after some time I haven't been, but due to a lot of STEM outreach and volunteering, I'm getting back into gaming thanks to Roblox, so we have that connection there. Tabletop games, probably not so much, but my spouse, he loves tabletop games. In any case, in terms...
Just follow up on that a bit,
Sure.
what Genevieve was saying about what inspires us, and how so many times it is what we might see in a game, what we might see in media. And for my generation at NASA, especially the Jet Propulsion Lab, which again is in Pasadena, California, my colleagues, most of us have some sort of a connection to Star Trek or Star Wars. And you can kind of tell when you walk into our offices which one it might be, right? But it's not just that. The engineers that are a little bit older than me, they talk about how science fiction and the paintings of Mars by Chelsea Bonestall, if you walk into one of their offices, you might see that. And the thing that strikes me about that is given that I live in Los Angeles, where Hollywood is literally right next door, right, that we have things in common, that so many of our scientists and engineers and our artists and all the different types of folks we have at NASA can trace something that fired their imagination. And that's actually one of the reasons that there's actually an exhibit, a permanent exhibit at the Air and Space Museum in the Smithsonian to Star Trek, because so many scientists and engineers have been inspired by the show, and also by the inclusivity of the show, by the fact that Star Trek had people of all colors and backgrounds, and I know that also was something that made a difference as we were growing up, was to see something that said, no matter what your background is, you have something to offer.
No, and that's an excellent point. Thank you, Nagin, because one of the major themes too that I'm hoping a lot of us are thinking about is the theme of inclusivity in so many ways, and I think that probably goes towards game design with Roblox, as well as the work that many of us do. So that's an excellent point. Thank you. I'm going to stay away from the Star Wars versus Star Trek scenario, because I do like both. So that's, what I'm going to say for now. So in terms of another set of questions, so we're talking about these overall themes of overlap, but also in some cases differences. So games about rovers and navigating rovers on Mars seem so widely different. However, there are similar aspects. I think we can all agree with that, I would think. So you're building something and solving a problem. Let's talk about those differences and similarities. So let's go with Nagin and then work our way back this way. So Nagin.
So one of the things we were chatting earlier about what's involved in designing a game, and also what are some of the choices. Like in Mission to Mars, one of the first things you do is say, what is my objective? What game do I want to play? What experience do I want to have? And then what kind of rover do I build to answer that question? And boy, that is right on the money. That's very much what we do. right? The first rovers on Mars, my first rovers that I worked on were Spirit and Opportunity. So Spirit and Opportunity were supposed to find out, was there ever liquid water on Mars in the distant past? And the answer to that was yes. So then we had to design the next rover to say how long was the water on Mars. And so that question drove the rover's design. What kind of instruments did we need to take to answer that question? And what kind of rover did we need? And where might it land to answer that question? Which seems very similar to what you do at the beginning of the game, which is make those same decisions. What should my rover look like? What should I build to help me on this mission? And this is not uncommon, that the things you see in the simulations, especially one that is designed to be so realistic, is what we actually do in real life.
Yeah. One other thing I'd add in also with that is just kind of thinking about almost the similar ideas of mission controls that we have. Like, Nagin has the idea of a mission control in your situation where you have almost a very high stakes situation. And also at Roblox, Genevieve and I, we've both launched educational games on our platform where we also have these kind of high stakes mission control where we're basically talking with everybody, trying to make sure, oh, everything's going exactly as planned, or, oh no, something's going wrong. We need to like make some changes right now rapidly. That kind of practices a lot of just problem solving skills on both ends here.
I guess that leaves me with talking about differences, which is one of the best things about video games is that when you fail, you can go and do it again. So I have to say the fact that I can design a robot and be like, oops, I forgot the oxygen, because I'm supposed to be driving this rover on Mars. In real life, I think if I forgot the oxygen, I would not just like happily pop up back in my lab, be like, all right, I'm gonna go put oxygen on my rover. So I think wonderfully games let us connect with these subject matters in a safe way where I can forget my oxygen and go back and correct the problem.
Right, we are, in our case, we can't really go back. Once we've launched and once we've landed, when we have a problem, the only thing we can do is change the way we operate on Mars or change the software. We can't change the hardware because we don't have an astronaut to help us, and the rovers are not necessarily going to come back. But there are so many things that happen every day that we have to find a way to work around. Last week, we were trying to drill into a rock on Mars, Mount Meeker, and it was very, very hard. And the scientists really wanted to get a sample from this particular boulder. And we tried multiple different ways, and it was just too hard, and we actually broke a bit. Not the whole bit, but we chipped one of our bits. And so then you go into, okay, that tells us something about the rock because it's very hard, but now the scientists have to then say, okay, where, shall we just go to another rock right nearby, or what should we do now that this didn't go as we expected? And we knew the rock might be hard, right? And also, again, you can be driving. There are failures on Mars that are show-stopping in the sense that, like, when we landed Spirit and Oppie, 2 out of 3 missions to Mars failed. So failure is part of what you do, but you learn from it. You might have seen videos of SpaceX as they're learning how to do the amazing things they're doing with reusable rockets. You see rockets blow up, right? And the challenge there is a failure isn't a failure unless you don't learn from it. And these guys have the job of, when you decide to play Roblox, when you decide to have a Roblox experience, you expect the platform to be working. You expect the app to work. And they're part of the team that, just like us working 24/7 on Mars, they are working 24/7 on this planet. to make sure that when you decide you want to go in and have a Roblox experience, that everything is working for you. So just so much in common.
Absolutely. And one other item too is for all of these examples that were provided, one of the major themes that I think we can think about is before we deploy a product or some sort of output, you could use software to simulate a variety of parameters and other factors before you build these objects, before you go on a mission. And we'll probably hear about that a little bit later, but just to combine almost everything that each of you have said. So, but these are excellent points. And we're going to go, speaking of, I know I heard at least one person mention there may be some challenges, perhaps. So this is for Genevieve and Peter. What are the biggest challenges in designing a game? Very curious.
I think the biggest challenge is deciding exactly what you want the game to be about. There's something that happens when you're a new game designer. Sometimes you might be like, I have no ideas, but mostly you're going to be like, oh my God, it's going to be so cool. It's going to have forests, and it's going to have space, and I'm going to have an ice cream truck, and you're just like, you want it to be about everything, and it's going to do everything, and it's going to solve all of the problems, right?
Yeah.
And then you realize it's just me, or it's just you and a couple of friends, and we only have so much time, so you have to figure out, all right, what is my actual goal? Like, it might be like, hey, I want people to come away understanding what it's like to have to drill or look for water on Mars. It might be something like, I want people to, I work a lot in education, so my examples are going to be a little boring. But like, I want people to understand what it is to be a white blood cell wandering around the human body. Or it could be, it's like, I just want people to be happy when they play this. I want them to feel a deep sense of calm. So sometimes you'll have very specific goals. Sometimes it is just a feeling. I want them to be scared. I want them, and so all of your decisions and that you make have to build around that pillar of design. Because if you let yourself get distracted, there's always going to be something more you could have done, but you've only got so much time.
Now, I have to ask a follow-up question. So I wonder with game design, how often you're looking into having a storyboard created beforehand? I'm just curious.
Every time. Every time. Not just like, hey, I made a storyboard, but I made a storyboard, I went back and I revised it. I took out some of my favorite parts because I had people look at it and they didn't like it or they didn't understand it or I missed something, or I talked to a real NASA engineer, maybe, hopefully, and they were like, that's not how it works. That's not all we're doing. Yeah.
This is great. And Peter, yes.
Yeah, I think also just like one thing to kind of throw in is just the benefits of a storyboard, something that kind of communicates these things visually, is you can say, oh, this is how my game starts. You walk into a room. That doesn't really tell you much, but you can get like a set of pictures of, oh, these pictures show what this room looks like. Oh, this is actually what's in this room. This is what you're doing through the room. And that can actually kind of give the story of your experience as you kind of go through it.
Thank you. And thinking of this theme of a storyboard, I like to highlight themes after what everyone has said, is a storyboard could be used in a variety of ways. So we saw one related to instructional design / game design, but I know for my own work at MathWorks, I actually build up, maybe I don't call it a storyboard, but some sort of kind of, I'm going to say, plan of action in order to highlight these are the steps that I'm going to implement as I try to build up this AI model. This is how I'm going to test it and what type of data I'm going to use. And I think all of us probably have that overlap in some way, shape, or form. And going over to Nagin, we're thinking about challenges still. And what are the specific challenges faced by you as a NASA Mars engineer in the space industry, and how do you address them?
So right now, we are, the challenges that we face on Mars for there are 2 rovers that are functioning on Mars right now, the Curiosity rover as well as Perseverance. And Curiosity right now is trying to get up a section of Gale Crater that it is very hard to actually traverse the terrain. So when you're working on Mars, even if it's robotically, your challenges can be something happens to the rover and there's some sort of problem, or that something happens on Mars. And Ingenuity, the helicopter that we have on Mars, it's our first drone, our first flight on Mars. The heli just made its first landing last week where something had gone wrong with its navigation. And so it made a landing that was unexpected, and so we figured it out again from the data. But there the challenge was in how its cameras were seeing the surface. I just checked my phone right before we started this panel to see if Percy had made it to Fall River Pass, which is where we're trying to go next in Jezero Crater. And as in other cases, the rover can drive itself to a certain extent, but it goes around hazards. And sometimes we come into work and we find that the rover was supposed to be over here, but it's actually over here because it was like, you know, trying to find a path, and it went, I'm done, because it couldn't find a way around the obstacles. So many of the challenges we face are actually based on the Mars terrain. There are no roads where we are. So when you're off-roading, things happen, and then we find a way to react when we get the information back.
Absolutely, and I'm going to ask a follow-up question. So as far as the path planning goes for any of the rovers, I'm going to ask it this way, was some sort of simulation implemented before they were placed on Mars, and what did that entail? I'm curious.
So that's a great question. Literally every day that we are, and today's Friday, right? So on Earth. So right now, the team that is planning what Perseverance will do over the weekend, we say, okay, based on where she got today, here are the activities we're going to do, and then everybody goes off and writes their commands, and those commands are absolutely run through simulations. And actually what we have found as one of the things we kind of do in the middle of the day is we watch animations, which are simulations of what the rover will do, what the heli will do, because we have found we used to kind of walk through the commands one by one, and now we're trying to do our planning faster on Mars, but we've also on the Earth for Mars. But what we've also found is that humans can find a problem more frequently when they're watching a visual simulation of what the rover is going to do versus looking at the detailed commands, and that's faster. So simulations and visualizations are run multiple times during the course of a mission control shift to help us plan and to see what might. Sometimes we'll run a simulation, this happened last Tuesday, and go, okay, that's not what was supposed to have happened. And so we find the thing that was missing in time to fix it.
No, this is great, and we're going to see this connection between what was just highlighted and Roblox with another series of questions. So I know you've answered part of this, Nagin, but I'll add in another piece. So we know that simulation has helped out with planning the mission for the rovers. So has virtual simulation and game development aided in rover navigation, training, and testing? So for the most part, that answer is probably yes, but is there anything you'd like to add?
So in terms of how, well, actually, I will say one very specific example is that we have, when we drive up to a particular area, what we call the workspace, then many different scientists have to look at where we are now and say what they'd like to do. So augmented virtual reality, especially, we started out using headsets, and we would actually send to our science centers around the world, because we have scientists everywhere, that we would send them headsets. And we would actually, in this VR environment, we'd walk around the data, so the game, the visualization was seeded by the real data on Mars, and we would then collaboratively say, okay, how about let's use our robotic arm over here. Now, over time, we found that when you're doing something in a worldwide, with worldwide involvement, worldwide players, we actually found that the headsets didn't quite work as well as more of the kind of thing you see in Roblox, where everyone's looking at the same simulation. And it's easier to get to and it's easier to use, right? I mean, even here, if you go up to the immersive experience, that is one floor up, when I was in there, I was struck again by how similar that is, because you can walk up to the pictures, even if it's just a really big picture of the Perseverance data here, and you can do that with more than one person and say, should we go here, should we go here? And an animation or a video game setting or a VR type setting, anything where multiple players can be in the same environment allows you to, it really speeds up the collaboration, because you're in the same environment looking at the same thing going, well, not there, let's take our image here, or let's put our arm here. So that concept, that idea of multiplayer collaboration is part of what we do every day as we plan for the next day on Mars.
No, and that makes a lot of sense. And one of the items that I'm thinking about now is, so we're thinking about simulation. How do we get these environments in the first place? Well, guess what? Someone has to write code. Someone has to develop them. So switching gears to Genevieve and Peter. So how do most developers get started on Roblox as developers? Also, what makes Roblox the best platform to get them into coding? So who would like to start?
Yeah, I think a lot of Roblox developers actually come in many different ways. For instance, I've been working with computers, honestly, since I was 3 years old. I got my start with game development when I was maybe 12. I found this little book at a computer store that had some computer language I never knew of. But many of our actual developers get their start oftentimes with their friends. They might have a friend who is building a game and they're asking, hey, can you try testing out this game for me? And then it turns out, oh, hey, maybe I can make a game too. And so then they also get involved building it. Or there's so many different people on YouTube or even TikTok or any social media where people end up making their own games, sharing it, and then you always get this idea, oh, maybe I could try this myself too.
Yeah, I want to talk about when Peter and I started with the Roblox education team, we talked to a lot of developers and we asked them that question. And I heard a really similar pattern that sort of mirrored mine and Peter's path. And that was they'd start out playing games and then maybe there'd be something about it they didn't like. Maybe they just didn't like the way it looked. Maybe something went wrong. Maybe they wanted a game that instead of riding horses, you got to ride unicorns. And so there was just always this point, they're like, I was playing something, and at some point this little light bulb went off that I would do it this way if it was my game. And then they would maybe play around with a tool, they changed things slightly, they would just start playing it. But oftentimes it went from this idea of playing, and then you start analyzing and getting ideas, and then they would go and create a little game with their friends, and that would usually build into bigger and bigger projects.
This is great. And Peter, yes.
Yeah, and I think that's also kind of a great way of kind of also segueing into why Roblox is oftentimes so easy to make games. If you're wanting to make your own game, sometimes it's a little bit intimidating. There's a lot of things to do, there's a lot of things to start out with, but one of the great things actually about Roblox, coming as somebody who does work at Roblox, literally having a Roblox cert here, is Roblox is actually really quick and easy to basically get a game out. If you have a Roblox account, you can go ahead and make games for free. You can even use a template, change something around, add unicorns everywhere that you want, make everything neon colored. And then within 30 minutes, you have a link that I could just say like, hey, you want to play my Roblox game today? You could just pop it up on your phone and play a friend's game. And maybe Nagin's playing my game and thinks, you know what? I don't really like unicorns. Maybe I want to change everything into the Mars rover instead. And then you can customize it that, and all within 30 minutes or less. So it makes it just a quick and easy way to actually get going and get going.
That sort of 30 minutes or less idea. So I've worked with a lot of different game engines, and as a game developer, a lot of times it's really, or like maybe as a student, I would say, back when I was a student, I remember feeling the pain of like, oh, I can't afford the fancy software. I can't afford a developer license. I don't know how to go about getting a developer license. Roblox, it's literally, I want to say it's Command P or Alt P, I forget what the shortcut is, but you can actually just download it for free as long as you have a PC or a Mac. That's like the biggest barrier to entry, but everything is free, and then you publish for free. So.
Absolutely, and I think this shows a connection to a few topics that people mentioned earlier. So for developers in general, for a variety of organizations, you know, you have a common starting point where they played some game, they want to make changes, and they figure out how to make those changes. And as a part of making those changes, getting access to whatever programming language or tool it is has been a barrier for some people. So it's great to know that Roblox is definitely trying to remove those barriers, and I'll put in a plug for MathWorks. MathWorks is also trying to remove those barriers too, by having people be able to get access to the software, whether it's online or otherwise. Speaking of writing code, I've got to admit, the first time I wrote code was related to a Commodore 64. It's a long, long time ago, and from there, I've learned how to program in other programming languages, but I will never forget the whole theme of, oh, I have to do this in text. But we're seeing a big change right now where guess what? You have a lot of graphical programming taking place. I think that's making things a lot more inclusive for many people. So it's good to see that theme with Roblox and many other tools. And switching gears, so let's go back to talking about Mars exploration. Maybe we'll talk about some coding too, if you want. And what are your predictions, Nagin, for the future of Mars exploration, and how does it impact future game development? Maybe this is a collaborative answer, but Nagin first.
So we are hoping, NASA's hoping to be a part of an international mission to Mars in approximately the next 20 years. So I have to say I see a lot of the right ages here to maybe be the first astronauts that go to Mars, and I see a hand here that expressing interest, right? So right now we are doing the steps to try to get ready for human exploration. And right here at MIT down the road, we have a group that is operating an instrument that's on the Perseverance rover called MOXIE. And MOXIE, like in the movie The Martian, we are actually learning to make oxygen from the Martian atmosphere of carbon dioxide. And we can now make enough oxygen on Mars to keep a chihuahua alive. Wow. So as long as the MOXIE instrument is running continuously, we could keep a little bitty chihuahua alive. So we are learning how to do the steps of having the resources that we need, so that then when we send humans to Mars, they will have robotic partners, and they will also have the background resources that they need.
I want to say, in terms of like, how can that affect game development? Life mirrors art, and art mirrors life. Like, I'm hearing that, and I'm like, I would make a video game out of that in a second. Like, that could be so much fun. I'm so inspired by that.
Yeah, no, it's one of those scenarios where for, I guess, all of us trying to project and predict what may happen in the future, there are a lot of great things that I can see happening with exploration in space in general, and I often wonder about exploration in space and the connection with AI, because it's definitely one of the topics that's bound to come up, and not expecting an answer here, but it's definitely one of the trends I could foresee having an impact.
There are definitely advances, and when we're talking about AI, it's not the same as like the autonomy that we're adding to the rover to help it make decisions itself, right? We're talking about AI and its learned ability to do tasks that it takes humans quite a bit of time to do. We were actually just talking about this last week, in that we're looking at landing sites for the Mars sample return mission. And one of the things we experience is that, you know, if you look at the globe, the fabulous globe that is above us, that I love already, that you can't tell from orbit what the real rock distribution is going to be. And now we have a helicopter on Mars, and one of the things we try to do is say, okay, now that we can be at the height of about 10 meters, now we go, oh, there are a lot more rocks there. But basically, we get these images back, and honestly, because I asked the question, could we have, you know, an AI engine do that? We have to literally count the rocks in the picture. And that immediately, because we're trying to get the rock distribution, could we send a human mission there? Could we send a robotic mission there? But at this point, you pretty much have to have human eyes, because you have to kind of look at it and try to figure out information about the rock in a picture. And we are, no joke, counting rocks. And that's something that very much would lend itself to machine learning, but we have to know enough to, we could still do it, but we found by the time you tell the machine what to do and go through the learning process, because every time is different, you just might as well have a human do it, right? And so there are room for those kind of things in the future, but we're just not there yet with machine learning.
Oh no, I could definitely see that. And another piece too is, one big part of machine learning is pre-processing the data. So that's another big piece, and I'm fairly certain there's a lot of time, energy, and effort that needs to go into finding out, is this a viable option or not? So, but thank you. And believe it or not, we're actually up to the final question, believe it or not. So here is the final question. It is lengthy. Here we go. How do each of you believe that games and interactive experiences like this can inspire the next generation of scientists, engineers, and space enthusiasts? And I think we alluded to this a little bit earlier, but we can definitely add more. So who would like to start? And then we can continue from there.
I mean, I can say that as a lifelong gamer and consumer of books and sci-fi and all kinds of things, there's like this thrill of connection when I see something in a book and then I encounter it in real life. And then I have this mental model that I didn't even realize I had built of a city or a cuisine. That there's all of these things that I didn't even realize I know. And then when I hear, for example, that this game that I played, that where I got to go to Mars and I made my little rover and I had to go find water, and then a real life NASA engineer very, very calmly says, oh yeah, last week I was drilling on a rock. Like, just what?
Casually.
Yeah, like, oh, I just checked my phone to see how this rover was doing, and I'm like, oh my God, I have, in video games, I have piloted that rover, or that airplane, or whatever it may have been. So as an educator, I'm a big believer in showing people what they could be in the world. And there's the idea that people don't know if they can't be something they've never seen.
Right.
So by giving people the opportunity to actually go and see these things and realize this could be you, this could be your career. That for me is like the most important connection.
And I'm sure it's also very rewarding as well.
I love it. So I made a throwaway comment that like I think, oh, some of my examples are boring, but really my whole job is showing like how cool things like going to Mars or going inside of a human body are. Like chemistry is awesome, biology is awesome, and games about them can be so much fun.
I agree 100%. Peter. Yes.
Yeah, one thing I actually also wanted to add on, one of the beautiful parts of video games, and Roblox especially, is Roblox has a huge role-playing community where people assume all sorts of different jobs, honestly, whether you're a wildlife expert, there's even communities that are dedicated to doing space shuttle launches. And there's kind of like a wonderful thing where, oh, you can go online and kind of learn, oh, what does it mean to actually be a wildlife expert, like taking care of bobcats and wild animals without the actual danger of getting attacked by a bobcat yourself. It's a lot of fun in actually kind of trying out these different things before you actually get into it. And oftentimes trying this out makes you actually think, maybe I actually want to do this for the rest of my life. I've spent maybe a couple of years on Roblox planning out like imaginary rocket launches. Maybe I want to actually be a rocket engineer.
There are whole communities on Roblox that what they do whenever there is a launch, they have recreated what all of these different like areas look like, whatever like center it looks like. They have recreated exactly what it looks like, and they'll watch a launch, and then different people will be different parts. They'll be the person who's in the tower, or is in the rocket, or is manning the rover. So there are these people that on Roblox right now that they get together and they plan out, all right, you're going to be this person, you're going to be that person, you're going to be that person. That's your job, that's your job, and that's your job. And then the next week they'll try new jobs.
That is awesome, and I did not know that. Okay, there's so much more I can learn. And Nagin, please.
I just want to echo what Genevieve and Peter have been saying. It's fabulous that you can surprise yourself, that you can go into an environment and explore. And we have a tendency to say, well, I want to be in the movies, but I want to be an actor. And maybe not realizing that there are so many other parts of making a movie, of writing the script, of directing, of working the lighting, whatever that might interest you. We look at what other people do and say, doctors do this, not thinking about all the other jobs that exist in hospital and medicine, or looking at space and saying, well, the only thing I can be is an astronaut. And this is a way to explore that so many fields, almost every field, has room for everyone. And it's about exploring, and this is a way that you can do this from your computer. How incredible is that? So it's all about exploration and inclusivity and really getting a chance to see, what do you want to do with your professional career, or even in the fun part, in your non-work life, which can also, work can be fun, right? It's just, there's so many opportunities to explore as long as you have access to a computer. And I think that's amazing, and we're already seeing, as we get interns at JPL or other places in NASA, and when we ask them what inspired them, it's not just the movies on the big screen or the television. It's these opportunities to explore that can now come from gaming. And when they show up, they know what they want to do, and they're inspired by the mission. So I just feel like there's such a connection. And I'm so pleased that not just kids, but adults as well can explore other paths and see if they see themselves.
And with that, no, thank you for those words of wisdom from each of the panelists. And before we end, one of the things I like to highlight is, we can all lift each other up. And the way to lift each other up is to explore, to provide opportunities, to grow our communities, to make certain that people can do many of the items that were mentioned. So with that in mind, I want to first say if we could give a round of applause to the panelists. I think they did a great job.
Thank you.
And thank you so very much for joining us. And with that, we will possibly end our session.
Yes, I'd just like to say thank you to all of you. Thank you, Lou, for moderating. And so appreciate our guests, so appreciate you as listeners. I'd love to tell you after this, Nagin is actually going to be upstairs at the Perseverance Rover. So if you'd like to go up there and see Nagin and ask her any other additional questions that we haven't covered there, she can tell you anything you need to know about it and then some. And then Peter and Genevieve will also be around, as will Lou, if you have questions for them. And the last two things I would say, if you're not playing this Roblox game, Roblox is amazing, and we love it for this specific learning opportunity. And then in the back behind you guys, there's a QR code. If you would like to see astronauts moving around the museum, you can go scan that code and take a picture of yourself. It's a little code on a board right behind us. You can grab some pictures of yourself with the astronauts from the game. Thank you, everyone. Thank you, guys.
Thank you.
Thank you.